Hello, my name is Yaroslav Bolkov. I'm going to be presenting my video for my second argumentative exam for the class of intermediate mathematical modeling. So let's begin. We're going to first check the first problem. I just realized I have to do this very fast. So we want to get the moments of inertia for X, Y, and Z. So let's begin with that part. It says that it's a unit sphere, so I'm gonna take it like that, it's a unit sphere, and I'm gonna start substituting that to obtain X, Y, and Z. So here's where the values we get is gonna be the same, just in negative and positive. So we're gonna integrate that well in our free integrals over here. We're gonna be using each one of these formulas because they're given here right here for X, for Y, and for Z. So we're gonna evaluate those things in our triple integral. I will go as far as I could, almost in every case obtained like to the second integral, and from there I was gonna switch to I switched to polar integrals right here, polar coordinates, sorry. Here X R cosine, for Y R sine, and stuff like that. So once there, I use Symbolive to get to the final solution. So for example, right here, this is the one for Z, where we get a P of 5. Then I did the same thing for each one of these ones for X, for Y, and for Z. So I will go as far as I could get to the polar coordinates. It was the same case in each one of them. Around here, I got to the polar coordinates, and over here, it was the same. So I got X pi over 3, for Y pi over 3, and for Z I got pi over 5. So that's how I'll do this. I had this P well eventually is 1 because that's what the problem said. So I will just multiply. It didn't really change anything. So that's why over here it says P, because I just left it P, but then I realized that it didn't really matter because it was 1, so it didn't really change that much. So now for the second problem, because I'm short on time. So the second problem is asking us for the center of calculating the mass and for the center of mass. So first, what I did was, once again, I assumed it was a unit circle, so that's how I obtained the values for X, Y, and Z. Z was already given, was from 1 to 2, so I just obtained for X and for Y, and that's how I did it. So I used the formula I was given right there, using precisely this part right here for the P. P x y z equals x squared plus y squared by z squared. So that's, I got this one. I switched it to polar coordinates straight up. This one I just changed it to polar coordinates, and I use once again Symbolive for the polar coordinates part, and I got 7 pi over 6. That will be our mass. And then I was trying to I went for obtaining the coordinates for X, Y, and Z. So here's where something interesting happened, because it's pretty much the same formula for each one of them. The only thing that changes is X and Y and Z. So when I switch to polar coordinates, I will get that it's R. So once there with that R, well, when I took it to Symbolive with these polar coordinates, I will get that it's 0. So if it's going to be R in all three, I assume that's going to be, 0. And so the position is going to be 0, 0, 0. So it's going to be on the center. That's how I give this position. So, well, that'll be pretty much everything for this. How do I stop this?